In this video, I'd like to continue talking about the complex conjugate by looking at several example problems. And remember that if we have some complex number z, let me rewrite that we can say this is equal to a plus b times I, then the conjugate of the complex number z, which we write with a bar above it, is equal to a minus b times I. So essentially, the conjugate negates the imaginary part. And for this example problem, this is written in a way that's not generally typical. Usually, the real part is written first. So if you want, you can rewrite this as 4 minus 4i. But the general idea is just to remember that the imaginary part will have the opposite sign in the conjugate. So for this problem, we can say that the conjugate of z1, we will just make the imaginary part positive. This will be 4 plus 4i. And remember that this conjugate is useful because if we multiply two conjugates together, these two complex numbers, then we will always get a real number. And as we looked at in the introduction video for complex conjugates, that can be very useful for carrying out division with complex numbers. But we will look at that in a later video. So let's look at two more example problems. And for this one, we have the complex number z1 plotted below, and we need to find its complex conjugate. So one thing to keep in mind, graphically speaking, is that conjugates are always reflections about this real axis. So it will be a mirror image on the other side. But we can also remember it more numerically that we just negate the imaginary part and the real part stays the same. So our imaginary part is at -9 or -9i. The real part is at 0. So when we make the imaginary part the opposite sign to find its conjugate, it will become positive 9i. And you can see this if you write out the number explicitly. z1 is really 0 minus 9i, and we don't have to write the 0 here, but it makes it more explicit that this is a complex number of the form a plus bi. And when we find its conjugate, we put the bar above it, we would have 0 plus 9i, or just 9i, which we were able to graph right here. And again, you can see that it is a mirror image on the other side of this real axis. So let's do one final problem. And to find this conjugate, let's put a bar over z1 right here, and we just need to make the imaginary part the opposite sign. So if we want, we can rewrite this as -6 minus 4i so that it's in a more typical notation of complex numbers, or we can just make the imaginary part positive since it's negative starting out. So the conjugate of z1 is really positive 4i minus 6. And like I mentioned, if we want, we can also write this with the real part first and the imaginary part second, which is typically how complex numbers are written. Now, I do want to mention, sometimes when finding the conjugate, you might just see this complex number with a bar above it. So both of these notations are used often and they are interchangeable. But by putting the bar above this, we want the conjugate. So again, we make the imaginary part positive and get 4i minus 6.